So I have the good fortune today of having a little chat with Chris Wright, who is the CTO of all of Red Hat. So Chris, you've been in open source communities for quite some time.
Yep.
Why don't you talk a little bit about the communities you've been playing in, contributing to, and sort of bringing into Red Hat as well.
All right. Thanks for coming this morning. I did a little run. I only got slightly lost, and I was impressed by the neighborhoods, which were pretty fancy looking around here. So it was a fun place to visit. My background is I really got into open source initially through high availability. I was working on a project. I worked for Lucent, and I was responsible for 5 nines for our platform. And we had this awesome process where once a quarter, my job would shift from procure a solution to build a solution repeatedly. And so through that process, I got involved in open source communities. And even though every other quarter, my job was to procure something, I kept at the community because I just enjoyed it so much. And the initial kind of exhilaration of being involved in something that was technically complex and working with people who were really smart developers was super exciting for me. And it completely shifted my career into open source. I started working in the kernel, and I worked in the security space with maybe even some folks here. And then I got into virtualization. I actually joined Red Hat to help Red Hat become a virtualization company. So at the time that I joined, Red Hat was really focused on RHEL. The JBoss acquisition hadn't happened yet, and we had yet to deliver a product that was hypervisor-based. So I was a hypervisor developer, and over the course of history, that space went well beyond just low-level virtualization at the kernel level and up into the orchestration pieces and system management pieces, and ultimately what became known as cloud. And I kind of grew along that journey, and the networking portion of that process got really interesting to me. I spent a lot of time in the networking space and building kind of next-generation networking infrastructure that's virtualized and accelerated and offloaded to hardware, and here we are today. So.
I feel like you're incredibly modest, but that's okay. I mean, I think you've made some pretty significant contributions to the kernel and software-defined networking and all those things. And so one of the great things that Chris has the opportunity to do today is be that leading edge of insight for Red Hat into open source communities, right?
That's right.
And I think we all know that open source communities are really changing our industry, changing IT modernization, changing every single thing that we're doing. And so, Chris, let's start talking a little bit about AI and machine learning. What are you seeing sort of on the outside edge in open source communities today in that arena?
Straight to the crux. All right. Well, first of all, I would double down on what you said, which is innovation to me, the innovation engine for the industry is open source communities. So if you look at things like AI, or blockchain, or kind of pick your buzzword, those projects today are happening in open source communities. AI is a great example because it's got such a long history. It's not new. The technology is absolutely not new. It's got a strong academic kind of backdrop, and academia and collaboration are things that really go hand in hand. So open source communities, collaboration, science, academia, I think these things naturally fit together, so it's not surprising to me that open source communities are driving the frameworks that make machine learning so accessible to data scientists and developers today, which if you think about why now? It was a big thing in the 80s. Why now? It's number one, the world's changed, so we have accelerated hardware environments that actually can do model training and model inference in meaningful times.
Right.
So it's not weeks or longer. It could be hours or less to train a model and then query a model. And then frameworks have made the kind of model development and model training so much more accessible to an average developer or data scientist. So you don't have to be buried in the hard math part of what's really going on behind the scenes. So that's pretty exciting. I mean, we're at a space where AI is like, it's not just kind of theoretical, it's real, and it's impacting business. And it's actually been there for a while. So if you think about an average day, you do a Google query, the results are fed to you driven by AI in the background. So the PageRank algorithm is AI-led. The ads that are placed in the pages that you click on through the AdSense program is also machine learning, recommendation engine led. So this is stuff that you're using on a daily basis, and you have been for years. It's just now getting to the point where it's accessible to everybody.
So there's not actually a person reading my Gmail and then picking the ads that are going to show up for me? That's not happening anymore?
You could, if that's what you need to believe, we can go with that. We can go with that.
No, that's good. And I think the other thing that's very interesting, you talked about frameworks. AI and machine learning algorithms are really difficult to develop, right? They take really smart people who understand a lot of math. And so now with the frameworks, we're able to expose those capabilities to more of the business folks.
That's right. That's right.
How is this new AI, machine learning type of world going to impact the way that our customers, whether they be in the government or even constituents, interact with one another and their government services? What are some of the potential there?
I'm sorry, Dave. I cannot answer that. I think a big part of it will be how you interact with computers, and how you interact with the system is evolving. So clearly you can talk to computers today, and you can interact with bots. The bots are backed through machine learning and natural language processing models. So that kind of interaction will become, it's already sort of there as the norm, but it will really become the norm. And what we have behind the scenes is still a lot of low-hanging fruit to just make data accessible. We've done some projects with a number of different governments around the world, just bridging the gaps between data sources. So there's points in time where the data is really redundant, and the way to get it from point A to point B is fax. And that's not that long ago, like maybe even last year in some cases. So getting the data to be shared is a key part of then creating an environment where you can do build models and create insights. Right. So we've done work on the procurement side with GSA to really look at asset tracking and procurement processes. The more data you have, the more accurate you can be in understanding what your needs are. So I think there's a behind-the-scenes thing where we can still do better, get rid of the process that still might include a fax and a redundant piece of information, and then applying both the kind of analytics side of understanding what's necessary for your business domain, and then how you interact, whether it's direct queries, you've got a bot that's a part of the process, being able to speak and just have a more natural interaction with the computer.
So as organizations start to use more open source code and sort of enter into this realm, one of the topics that's really high on people's minds, especially in this town, but in a lot of other places as well, is invariably security, right? And so security from the penetration perspective and sort of offensive, defensive, but also from a software supply chain as well. Talk to me a little bit about what you're seeing in that space and communities and sort of the role that we're playing there.
Well, so that earlier comment that open source is the innovation engine for the industry, what's the quote? With great power comes great responsibility. There is something that we need to pay close attention to, starting at that community level, which is when you're producing software that's going to be consumed ubiquitously around the world, what is your responsibility to be clear about the state of that software? So the full supply chain from the developer all the way through to deployment, developer being in an open source community, to pull that code internally, to build around it, to deploy, we need to be able to be clear about where code came from, what process or what sort of stage it is in your production pipeline, and then where it's been deployed. So that as we find vulnerabilities, which are inevitable, as we find vulnerabilities, it's more of a push button activity to refresh and redeploy, and you actually know what's running in your system. So the kind of struts fiasco should be an exception, not the rule, and that actually starts all the way on the community side, and then how you bring software into your development environments. You own some responsibility for that. So and we need tooling to help manage that. So it's not just hope, download a tarball off the internet and hope it was good, but understand really what you're putting into your system and into production. And there's actually some opportunities for AI in this context.
That was going to be my next question. What are the opportunities for AI, machine learning in sort of the analysis of this meta infrastructure that we're building?
You think about a build system generates a lot of data, production system generates a lot of data, looking at all that data and trying to understand when things work well together and what anomalies look like. So on the one hand, anomalous behavior can be a security issue. It could be, maybe not security, it could just be a spike in behavior, so it could be a performance issue. How do you respond to that? So it's something that we would kind of call AI ops, so trying to understand the state of your infrastructure based on the data that you're pulling out of it. Mm-hmm. And then similarly, as you're building, testing, integrating, and pushing code from point to point in a pipeline, you can get a sense of what works well and what doesn't, and try to really focus on the optimal stack, where that stack might be built out of different components and different versions. And if you look at what we've been doing in a project like OpenShift.io, where as a developer, you're getting some information about the dependencies that you're pulling in. Sorry. So you're hacking away on your POM file, and you're trying to pull in a versioned dependency of foobar, and you get an indication that was a bad version. And it could be something as simple as there's a CVE associated with that version, a security vulnerability associated with that version, or that version in conjunction with other components in the stack is known not to work well together. So that there's some interesting opportunities there for just understanding this. We're building more and more complex systems, and at the end of the day, we're not smart enough to figure out exactly what's going on all the time, so we need help. We need machine help. We need automation and tooling, and some of that automation is around AI.
And just the gross amounts of data now that are being generated, right? If you look at
all your email.
Yeah, all my email, that's right. Thank you, whoever it is at Google that's doing that. All the NetFlow data that you could be dragging in, all the system data. We have tools like Splunk, et cetera, et cetera. But the reality is sort of aggregating all of that data and doing that analysis is beyond the scope of any individual to possibly do.
That's right.
You mentioned that you sort of started kicking this open source thing around in the world of clustering and high availability. It was really hard back then, right? Like you would have fencing and shared file systems and all kinds of craziness in order to do that, and some of that still exists.
Yep.
But I think a lot of that's really moved into the realm of Kubernetes today, right? That's where we're seeing a lot of the more high availability. So talk about what you're seeing in that Kubernetes space and what's exciting there.
Well, first and foremost, I think there was all of the HA work at the time was about ensuring the platform was always there. So the application could be pretty unsophisticated and make assumptions about an always functioning underlying platform. And I worked on a system at one point where we had fault-tolerant hardware. And the fault-tolerant hardware, it was actually like an amazing solution. The fault-tolerant hardware, everything, power supplies, CPUs, memory. And we had this issue, which was, it essentially was doing lockstep replication of instructions on each CPU. We had this issue where it was a great system for replicating a bug from one side of the platform to the other. So it was pretty easy to crash the entire system because you would just execute faithfully exactly what was happening erroneously on both sides. Today, we're really taking a completely different approach, which is say, look, the reality is failures happen. And at a platform level, we need to build a distributed system that allows you to recognize when a failure has happened and redeploy. And redeploy, part of that's just scaling out, up and down. And part of that is managing faults. And part of that fault, there's a fault detection process, which we always had. And then there's a fault response, which in this case would be deploy another instance of the same code. And then with a distributed system, you also have to route traffic to it. So that's make sure your load balancer is aware to push traffic into that new system. And ideally, you've already had multiple replicas running anyway. So when one failed, there's still another set taking requests. And the new one that came online is just helping you keep your capacity. So more of a kind of +1 sparing rather than a active standby, which is what we were doing back then.
Right, which is, I think the subtext to that though is it's painfully expensive to build that kind of infrastructure, right?
It's 100% more expensive than something simple because you're doubling everything that you're trying to, you need full redundancy, you're trying to eliminate all single points of failure. And today with a kind of N+1 sparing type of model, it's a fraction of a percentage increase in cost for the actual infrastructure. And we're trying to manage the complexity, again, at a system level or platform level. So when you're deploying code, especially if the container image that you're deploying is stateless, you don't really have to get involved in what happens after that, which is failure happens, a pod failure happens, and you redeploy somewhere else. That's something that the platform is taking care of for you. And I think that's, in a sense, really keeping the initial attempt was keep the code simple because the platform just is always there.
Right.
It was stateful and complicated because it was going to scale up and all that. But today it's keep the code simple because you can just start a new instance of it, and the platform is managing that for you.
And in highly regulated environments, like the federal government or banking, we find ourselves doing a lot of exercises around disaster recovery, continuity of operations, shut this data center down, move your workload there. That's incredibly expensive and time-consuming as well. In this scenario, it's just kind of built into the infrastructure, right? That COOP or DR is just part of how you go to market, right?
That's the goal. I mean, we want to make sure that you have failover capacity, redundancy, not just within a single cluster, but across clusters. So geographic dispersed regions, so you can have redundancy and backup. And modern cloud-native applications are written that way. You look at a public cloud provider and a customer like Netflix, who's been very well established as a leader in the space and understanding how to make use of this kind of multiple cloud infrastructure. The reason they remain available is because they're deploying across multiple regions, and really it's this big failover mechanism that's recognizing where things are running and where traffic is going and managing all that.
And you'd have to be intentional about that design, right? That's something
That's right.
You really have to be aware of and think critically about as you go forward.
Yeah, that's right.
So, another thing that I find kind of interesting as we're speaking about Kubernetes and we get sort of to two of your roots, right? We're beginning to see some virtualization moving into Kubernetes, which sort of gets back to some of your roots. What are your thoughts around virtual machines running in containers across clouds, like cats, dogs?
Well, it's pretty interesting and it's fun. So actually I started in virtualization because of security. And I started in security because of virtualization. So I was working on, availability. I was working on HA, and HA had this notion of a vServer. A vServer was really front-ended by a load balancer. And then we're looking at ways that we could take that same idea and create isolation out of it. And that isolation was essentially containers, except we didn't call it containers then. And then that grew into hardware-assisted isolation, which is virtualization. And now we're looking at, well, you don't always need hardware assistance to create an isolated runtime environment. Obviously, we had that for a long time, and with even a chroot environment in Unix and jails and BSD and zones and Solaris. Where they intersect, where you have hardware-assisted containerization, I think is also interesting, and certain regulated environments care deeply about that so that you can understand what your kind of attack surface is from application code to the hosting environment. And where we can, in my ideal world, we'd have a way to do scheduling and orchestration across a cluster with one tool,
right,
for applications. And so we've actually been investing in that kind of investigation with a project called KubeVirt, which allows us to run virtual machines with Kubernetes as a scheduler. So there is this kind of interesting intersection that's happening, and as we kind of learn more and more about what's possible there, I think we'll see some convergence of how you can schedule applications and create these peer relationships between containers and virtualization, and then also what does it mean to have a machine isolated container type runtime environment.
So Jamie Duncan likes to say that the only reason virtualization was invented was because someone needed another port 80. I don't know that I necessarily disagree with that. I think that's a lot of what we use it. So I find it so interesting that, if you're familiar with SE Linux and KVM, we have the concept of SVirt, right? And now we have sort of this KubeVirt. Of course, SE Linux wrapped around those containers as well. What are some other sort of interesting intersection points that you're seeing on the horizon of technologies?
Well, take all of that as low-level information or infrastructure, and then use that as a data source for anomaly detection. I think that becomes really interesting. Again, having spent time in security, one of the challenges in security is writing rules ahead of time that actually understand the state of an application. And we considered that at the time a halting problem. It's actually really difficult to understand how a system is going to execute over time, especially when you have things as simple as configuration files that can change how the system is going to behave in a hard to define way. And so today, I think there's a different approach, which is, especially as you have better and better testing coverage through a CI/CD pipeline, you can look at how your application should behave and quantify that with information that you're pulling out of the system that's this low level at the container, at interfaces, and with enforcement with SE Linux policies as part of the picture, ultimately giving you better sense of where anomalies are happening in the system, and then the ability to do some kind of remediation on top of that, and even looking as a distributed system globally across your infrastructure. And there's actually interesting work already happening today where some systems are capable of kind of identifying, well, you look like you're working in the HR group because of the behavior, the packets that you send on the network, the systems that you interact with. So we'll classify you over here. And now, if you start copying files from the finance group, that's going to look a little suspicious. So we're already there. I mean, those are systems that are already being built today. So I think creating the infrastructure, getting the telemetry out, and then feeding that into classification engines and anomaly detection engines is sort of the state of the art for what we're doing with security.
So machine-based decision-making based on that metadata, sort of wherever it is. A lot of that's going to require a lot of portability, and a lot of folks right now are thinking about things like function as a service and cloud portability. In the realm of function as a service, how do we avoid getting locked into a single provider or implementation? What do you see in there?
Don't use Lambda.
Don't use Lambda.
I mean, the reality is any cloud service provider's native functionality is going to be entirely designed within the realm of that cloud. And so to the degree that you're trying to make use of that cloud and really tie yourself to that infrastructure, then make use of it. To the degree that you're trying to avoid that type of kind of tether or lock to that one specific environment, then you need to look for a different way to provide the same functionality. Certainly what we're investing in is building that abstraction layer with Kubernetes so that you can take applications anywhere. And then there are open source projects that provide function as a service. We're working on a project called OpenWhisk and ensuring that OpenWhisk itself runs well on Kubernetes. And now you have a portable infrastructure that you can take with you and you can write functions. And there's some interesting challenges about the event triggers that trigger a function. And certainly one of the benefits of a service like Lambda is that it's completely integrated with the rest of the infrastructure, so you get natural events coming out of other AWS services. So tying in those same kind of event triggers into something like OpenWhisk is entirely possible. It's just, there's work that has to be done to make sure that you're building a system that is then portable across different infrastructure, so you're not tied to a single cloud provider, which I like the description of the cloud or the public cloud being something you might want to look at as the next mainframe, where everything gets tied into that single vendor's view of the world. There's some, there's some interesting aspects to that, and there's some benefits that you might see, especially in the short term. And it's also something you need to pay attention to in the long term. Is that where you want to go as a business and be trapped to that one mainframe that most of our customers today are still trying to get off of 20 or 30 years later?
I think every civilian CIO that's ever come into their role has said they were going to be the one to finally get their agency off the mainframe. And I think we certainly go through CIOs faster than we go through mainframes, I think is the only statistic that I can take away from that. So, open source communities aren't what they used to be, right? It's no longer just some guy and his or gal in their basement making major code contributions. We've got huge industry partners as well partnering with us. So I know OpenWhisk, we've got a variety of partners there.
Like IBM.
IBM, thank you for sponsoring, by the way. And then throughout OpenStack communities, talk to me a little about the nature of communities as we see them today.
There's certainly maybe a myth, maybe it's outdated, but certainly there was a myth that open source communities are, it's tie-dyes and barefoot and hippies in their basement. And there was there's some real aspect of truth to that, which is a group of people who are passionate about not just the technology, but the movement behind it. Creating something that's open and accessible and kind of democratizing the availability of developing code. Today, there are still what we would call hobbyists, people who are participating in it just for fun. And that could be a student, that could be a professional doing it in her spare time. But the practical reality is most of these people, well over 90%, nearly 100% are full-time employed. Mm-hmm. And there's an interesting balance that's happening in the industry, which is that kind of passionate, movement-oriented core of developers are surrounded by people who are paid for their day job to, quote unquote, just go hack on some open source project.
Right.
And I think the interesting piece is it's sort of shifted how we operate together, and so you're seeing more and more of these foundations. Certainly the Linux Foundation or the OpenStack Foundation or the Eclipse Foundation have more and more projects, and you have to ask why. Why is that? What's going on? And a lot of that is what I call the corporatization of open source development. And when I say that to the Linux Foundation executive director, he cringes. He's like, that's so negative. That's so, what are you trying to say there? I said, well, it's a little bit intended to be negative, but it's also just saying that's the reality. There are corporate developers who spend all of their time working on open source projects. And in fact, you could say, that's awesome. Mm-hmm. And we won. Like, here we are, we won. And the thing that's different is corporate entities don't fully understand how they want to play in the system and what IP looks like and what their vulnerability or concerns around liability are. And so we create this governance structure, and then we have voting mechanisms to say who's in charge and make sure we have this theoretical level playing field that we didn't have to do in the past because we just had passionate developers that were really excited about building technology. And today, when you have, the honest reality is when you have a lot of value, industry value created in this space, you actually have to be really careful about how you create a community to preserve the community aspect and not have value distort how the project evolves and how things are developed. So I think corporatization, I intentionally use that word to be slightly negative, but also recognizing that it is the way we do development today. And we have to be clear that the way we are influential in a community is with developers, not with a brand and a bunch of dollars and some skewed voting mechanism that prefers one company over another.
I think we still do have sort of the long tail, though, of developer or of contribution, I would say, which is the guy or gal who's running whatever piece of code in their infrastructure and finds a bug.
Yeah.
Right? And then that's the person who goes in and makes that pull request. And that's incredibly valuable as well. I don't know how we curate that over time.
Well, part of it is every open source project has, to super simplify, developers and users. Users are always a part of the equation. They always have been. There was a point in time where the developer and the user looked a little more similar, and maybe they were the same person. But today, it's a little more distinct. And so most of these development communities have a way to really bring users into the fold and take that feedback directly. It's a critical part of the whole mantra of release early, release often, which I'd argue is what turned into today's DevOps and CI/CD. That whole idea is about getting feedback directly from users. So we fundamentally rely on it. And my personal experience, going back to the very beginning, that find a bug and report it and be involved in fixing it, that's an exhilarating experience. And so we kind of nurture growing the community through ensuring that we're always taking feedback and working together with users and developers. And I know some of the larger projects have operator groups or user groups that are focused on understanding the user needs, not the developer view of the world and what users might want, but the actual users' needs, especially when you're operating a big distributed system where instrumentation becomes critical, and the developer probably did it all in one box on their laptop. And they can kind of easily inspect what's going on. It's quite different when you're operating at scale.
Yeah, it's a whole. I think there's a whole behind the scenes of communities. I once heard that Google actually has an on-call rotation for pull requests to Kubernetes. Right, like that is an active job that someone has to have, right? So you have to be very intentional about it.
I thought it was just Clayton doing all that. Is he in here?
He'll be up later.
Okay.
So it often feels like innovation is happening somewhere else, right? New York or San Francisco or wherever else. But we've got a lot of those resources here in DC. What are your thoughts about people being able to get involved here in DC with open source activities?
Well, there's two distinctly different ways. I live in Portland, Oregon. I've been an open source community member for probably 20 years now. And most of the people I interacted with were remote from me for the last 20 years, even still today. So there's always the ability to just go get involved in a community. You don't have to do anything other than show up, send some email or send a pull request. So there's that level of the inertia barrier. The barrier to entry is really low for a distributed community. And that's one of the awesome things about it. Then there's a localized view of the world, which is there's user groups, there's things that we do here locally. We've got great resources. I know Jamie and John are here, and they wrote the book on Kubernetes, right?
Yep, exactly. They're good resources.
Awesome local resources. And that's, so on the one hand, you can go directly to the community, which is a distributed community, and my experience is those are welcoming communities, independent of where you are residing. And then locally, you can build the kind of face-to-face human connection and human communities by participating in user groups and meetups and exactly. all the things that are local activities, which are really important because at the end of the day, a community is made up of people. And the way people operate is through trust relationships. And there's all this AI and even video conferencing and all this stuff. We haven't quite figured out how to really understand each other without sitting down and sharing a beverage or a meal and getting into a face-to-face argument, not just an email argument over some arcane technical details. those are the things that really create a different level of trust and a different kind of learning. So I think there's a huge opportunity of getting directly involved in a local community, and then you can share that more broadly in the distributed communities.
Scars build bonds, right?
That's right.
Cool. Well, Chris, thank you so much for being here.
Yeah, you bet. Thank you.
I really appreciate having us.